Next, we're going to talk about instantaneous velocity and speed. And instantaneous velocity and speed has to do with the speed or velocity at a given moment. So it's the instant that the velocity is at a particular time. Instantaneous velocity, we usually refer to it just as velocity. So when we're talking about average velocity, we say average velocity. Velocity is instantaneous velocity. Now, velocity has to do with derivatives. It has to do with calculus. So if you haven't taken calculus before, that's okay. Part of this lesson, we're going to go over some basic calculus rules, but this is the equation for velocity. It's written as the limit as our change in time approaches zero of our change in time, or excuse me, our change in displacement divided by our change in time. What this basically means is um, we're finding a value for our instantaneous velocity when our time is very, very close to zero, because that is when something is happening at one instant moment. At that very instant, time is not quite zero, but a very, very small number that is close to zero. So as our change in time becomes smaller, the average velocity starts to become less and less of an average velocity and more of an exact velocity at a certain time. All right, so the next part is speed, and that's the magnitude of velocity. Speed, again, does not have anything to do with direction, so speed is always going to be positive. Let's look at another position time graph here. So we have this position time graph of 2A, and it's plotted with position and time. So we don't really have a question yet. We just have some information. We have these points A, B, C, and D. But we can look at the intervals of these graphs, and this is how we write an interval. This is where x, or our displacement, is between 0 and 1. Now, I actually wrote this a little bit different. I said x is between 0 and 1. I probably should have written s for this, or maybe time, because s is seconds. I maybe should have written t is between 0 and 1, because when t is between 0 and 1, that's between there and there, and our velocity is 0. So this should say t on it. And when t is greater than or equal to 9, that is here, then our velocity is also 0. And I wrote x because typically in math, and I guess not always in physics, we have our displacement. We call that x, and it's on the y-axis. And the time is on the x-axis. So that's why I should have written t here. It's a little bit different in physics than you might see in a mathematics course in calculus or pre-calculus. But that is how you read intervals. So constant velocity is when t is between B and C. So here and here, we have a constant velocity. And we can identify that we have a constant velocity because there is a slope that is continuous. We have a linear relationship here. So that shows a continuous straight line that's going up at an angle. And our slope is our change in our displacement divided by our change in time, which equals our velocity. And we can solve this with finding the slope between these two values as well. So we find the slope using x Go back here so I can write on this. So we find the slope. So m is denoted as slope in mathematics, and we find the slope by y2 minus y1 over x2 minus x1. And so here, if we identify what these points are, this point is 3, 4, and this point here is 8, 24. And so we can call this our x1, y1. This is x2, y2. And this probably is reviewed for many of you from other math courses. And so that's what our slope is, and it's related to velocity. Now, when we simplify this, we get 20 over 5 or 4 meters per second. So between point B and C, we're going 4 meters per second. And again, this should say T, and this should say T. All right. So we still don't have a question for this. It just says plot VT. So plot VT means that we want to plot the graph of the velocity graph. So we have the position graph given to us, and now we want to plot a graph with time and velocity. This gets a little bit complex here. So velocity is the derivative of position. This is something that is crucial to understand in physics. This is a very important concept. So if we know the slope of our line, then we can determine what the velocity is. So this is a graph. This second graph is the graph of what's happening with the slope here. So if we look here at between B and C, we have a constant velocity. Our slope we found was 4, and the graph here tells us that the velocity is 4, and it is constantly 4. That is the most important part about understanding what these two graphs are saying. We can take the derivative of velocity and find the acceleration. And here we can see what's happening between 1 and 3 seconds with velocity. There is a constant velocity, and that is shown on the acceleration time graph of a constant acceleration. So there's not a constant velocity. The velocity is increasing at a constant amount. And because the velocity is increasing at a constant amount, the acceleration is continuing at that same value. So when we find the slope of the velocity, that is our acceleration. And the slope between these 2 points is equal to 2. We're going up 1, 2, 3, 4, and we're going over 2. 4 divided by 2 gives us 2. And so we have 2 for our acceleration. Next, we're going to talk about derivatives and how to solve derivatives and how derivatives are written, because you might see this in other physics courses, as well as possibly other calculus courses that you take in the future. So when we find the derivative, the most simple way to do this is to use what's called the power rule. And to use the power rule, what we do is we figure out what is the exponent on each of our variables. Whatever that exponent is, we bring it down in front and we multiply the coefficient, the number that's in front of the variable, times the exponent. So this one would be, we write the derivative like this. That's one way we can write it, y prime like the derivative. And we can say -2 times 1. And then we still write the x there, but now we're going to write the original exponent minus 1 from it. If there is no if there's no variable, then that term goes away. So this is just going to be plus 0. And you don't have to write the plus 0 if you don't want to. So we write y prime equals negative 2x to the 0. Y prime equals negative 2 times 1. Y prime, sometimes PowerPoint doesn't let me write on here. We'll write it over here. Y prime is equal to negative 2. So that's the derivative of this function. And that makes sense. Our derivative is our slope. And our slope for this is negative 2. All of our slope-intercept formulas are in this form, and m is always our slope. So that's how we find the derivative. You might also see the derivative written like this: d dt, d dy, or d dx. Sometimes is written like that. dy dx is another common one. But we write the derivative with the prime sign. That's a universal way to express the derivative. Here are the answers for these other ones. So again, we just take the power of whatever the power is, bring it down to the front and multiply, and then subtract 1 from that power. If there's no variable, it just goes away. Now the product rule is a bit different. There's a few steps that we have to do with the product rule, and that's when we're multiplying two different values and then finding the derivative. Now, you can multiply this out first so that it's a standard polynomial and then find the derivative, or you can use the product rule. And we might need this in just a couple different calculations that we do. So that's why we're going over the product rule. So the product rule says this. It says we take the derivative of the first piece times the second piece, but we don't take the derivative of the second piece. Then we add the first piece, not the derivative of it, and we multiply times the derivative of the second piece. So the derivative of the first term is negative 3x squared times just the second portion of this, the binomial, is 3x to the fourth minus 2. Now we're going to add the first part, not taking the derivative of the first part, times the derivative of the second part, the binomial. So we take the derivative of the second part, we get 12x cubed. We leave all that there the same. And when we multiply this out, we get negative 9x to the sixth plus 6x squared. We use a distributive property here, and then we're gonna add negative x cubed times 12x cubed, and that gives us negative 12x to the power of 6. We can add these two like terms together, negative 9x to the 6th and negative 12x to the 6th, and we get negative 21x to the power of 6. And then the plus 6x squared just stays there. So that is the product rule. Here's one if you want to write it down and practice. And there's the answer for the product rule. All right, and here's a couple others. We're going to skip through these, though, and go to the quotient rule. So the quotient rule is very much related to the product rule. It has to do with finding the derivative of the top portion, the numerator, times the bottom, the denominator, and then we subtract the top, the numerator, times the derivative of the denominator. Then we divide everything by the denominator squared. Here's how we do this first one. So we do the derivative of the first times, which is just 0, times the denominator. So derivative of numerator, 0 times denominator, minus numerator times derivative of the denominator, all divided by denominator squared. So we've already done the derivative of 2 is just 0. That's really easy. All of that crosses out. And now we're left with this negative over here, negative 2 times derivative of 2x to the fourth minus 5. The derivative of 2x to the fourth minus 5 gives us 8x cubed. Multiply that by negative 2, and we get negative 16x cubed. And then when we square this binomial, we don't just bring the squared to both of these terms. We have to actually expand this out, and it becomes 2x to the fourth minus 5 times 2x to the fourth minus 5. And then we have to multiply all four terms like that. So we would get 4x to the eighth minus 10x to the fourth minus 10x to the fourth plus 25. And then we get this final answer down there for our denominator. So that's the quotient rule. Again, very much related to the product rule. All right. We are going to possibly see some derivatives with the chain rule, and the chain rule is a little bit more complex. If we happen to see things with the chain rule in this course, we might maybe only have one problem with the chain rule. But the chain rule tells us that if we differentiate a square root function, first of all, we can write it as to the power of 1/2. And then when we find the derivative of that, we find the derivative of the outer function, and we multiply it by the derivative of the inner function. And here's what that looks like. So we use the power rule, and we take the 1/2 and bring it to the front for the first part. We subtract by 1, and that leaves us with an exponent of negative 1/2, because we had half and we're subtracting 1. So 1/2 minus 1 is negative 1/2. Now we want to find the derivative of just the inside portion of our parentheses. And so when we do that, that's 4 times 3. We're bringing this 3 down, and then we're going to subtract 1 from the exponent, and we get 2 for our exponent. So this becomes 12x squared. And we really can't do much more with this. We can only multiply the 12x squared by the outside. We could think of it as the coefficient of the binomial term, and you get 6x squared times the quantity 4x cubed minus 5, all to the power of negative 1/2. So that's how you do the chain rule. Another couple derivative rules we're going to go over. The derivative of e to the x is just e to the x, and the derivative of the natural log of x is just 1 over x. That's just something to remember. Okay. And here's the workbook that is associated with what we've covered with instantaneous velocity.